reclaiming calcium carbonate from ash at Shaw Industries. There are two plant burns waste carpet and produces fuel for power to the other plants in the area. They produce an ash that has calcium carbonate in it, and they would like to reclaim it to reuse in the carpet manufacturing process. It's used as a backing to mix with latex. Goes under on the underside of the carpet. The dry ash itself is about 70% calcium oxide, 25% calcium hydroxide, and a little bit of calcium carbonate. As a dry ash, it's pretty volatile, so they usually do hydrolyze it immediately when it comes out, which is adding water, and that ends up with mostly calcium oxide, and the calcium hydroxide precipitates into calcium carbonate at that time. Using that, taking advantage of that, we can precipitate calcium carbonate out. It's called PCC, which is funny because they refer to post-consumer carpet as PCC, so we have to be careful with the acronyms. We can also use a dispersant-modified wet precipitation with an anionic dispersant. There's a process out there right now that does that to create PCC that's very systematic and always is the same, which I think would be good. Carbonation is what we'll call this step, which is dry calcium oxide reacting with carbon dioxide to change it into calcium carbonate. It has a reaction enthalpy, so we have to be careful of the temperature change in our processes, our equipment design. This is what the process would look like. We're ironing out the differences between the solids, how the solids behave in water and how they behave when they're dried out. And then we'll have this more ironed out. But as of right now, the hydrolyzed ash will go through a filter and to separate out the precipitated calcium carbonate. And then the rest of it will go through a centrifuge and a dryer to dry it out. And carbon dioxide will be bubbled through it in a fluidized bed, which is pretty common to process gas streams coming out of power plants. If they need to clean the exhaust gas, they'll bubble it through calcium carbonate or calcium oxide and create calcium carbonate. So we're just going to do half of that, or I'm sorry, and then they'll do it again. But we're going to just bubble the carbon dioxide through the calcium oxide to create calcium carbonate. So many calciums in there. And right now we're working on refining the block flow diagram, and then we'll put it into KimCAD with our mass and energy balances and design the equipment. So that's what we're doing right now. Questions?